Well, greetings. In this video today, we're going to be taking a look at Chapter 9 in our course text, Elementary and Middle School Mathematics by John Vanderwall, about mastering the basic facts. There's really going to be two parts to this video. In the first part, we're going to focus on addition and subtraction. You know, those basic facts like 7 plus 6, 8 plus 9, 12 minus 5, and so forth. And the second part, we'll look at multiplication and division. 7 times 7, 42 divided by 6. So let's take a look. Before we start, I'd like you to pause the video and think about these 9 questions on the screen. And think about if the answers just pop in your head, or do you have to think about them? And if you think about them in some way, what is your brain doing? What kind of strategies do you use to get the answer? So press pause and try it out just for a minute. All right, well, let's talk about what you just experienced for a second. Well, with those, if we were in class and I had people share some thoughts on what just happened there, I think what we would see is that there'd be a variety of different reasonings that came out. For example, maybe if we're looking at 9 plus 8, there could be some people that realize, I just look at it and I see the answer 17. It just kind of pops in my head, and that may be there. But other people may realize, well, they notice that their brain actually does something, for example, like they ended up taking 1 from the 8 and put with the 9. So visually it might be something like this. They might say, well, I took 1 from the 8, put with 9 to make it 10, and I know it's going to be 17. And someone else may have said, well, actually, I know that I kind of thought about it as 10 plus 8 because I know that's 18, but we wanted 9 plus 8, so that was 1 less. So I knew that the answer was going to be 17. Or somebody else may have said, oh, I always think of double eights. I like double eights a lot. So I know 8 plus 8 is 16, and 9 plus 8 would be 1 more. So I put 1 more on there and got 17. And my point is that as we look at these, to go through, that there are many different strategies that we as individuals use to start thinking about math questions like these. It's not something that we all just learn from memory and have set in our brain forever, and that our brain actually is doing things to figure it out. And a big part of today's video is going to be thinking about different types of ways, reasoning strategies, to build understanding of what the basic facts are. So first, let's talk about, the phases of which someone goes through to learn their basic facts. So obviously the goal is to get to memorization if we can. If I just know 9 plus 8 is 17, it saves me time, it's efficient. But that's not typically where we start. As learners, we start with counting. With 9 plus 8, as we are first learning, we might actually take physical counters out to count that up, or we might start with 9 and add on 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm sorry, 17, and use different types of counting or counting on techniques. But in view of efficiency, as I showed on the paper, reasoning strategies start to take place that become more efficient. For example, like the making 10 strategy, or using 10 strategy, or the double strategy. And we start having other ways to get the answer. And through that, after some practice and use, well, our brain tends to start to remember that, well, it's 17. I've done this lots of times. I know it's 17, and now it just pops in my head. But the nice thing is if I've gone through these phases, if I forget it's 17, then I can fall back on reasoning skills to recreate it if it has forgotten. So that phase is going to be important, and today we're going to spend a lot of time on the reasoning phase to think about that. So again, for clarification, here's an example of going through that. If you look at part A, it's definitely a student in the counting phase. She was thinking of 7 plus 4, took out 4 counters, and then added on 7 more to get 11. Another girl in part B is on the reasoning phase. When adding 7 plus 4, said, well, 7 and 3 more equals 10, so 7 and 4 more must equal 11. Versus Sarah in part C, who just knows it. It's just there. And so that's the 3 phases that we're talking about today. So again, what I challenge you for a second is to think about this. Let's take the addition fact, 6 plus 8. Why don't you pause the video and see how many different ways you can think about someone might figure out 6 plus 8 if it's not a fact they just had memorized in their head. Okay, take a pause and just write some things down. Think about it for a second. All right. Well, when thinking about it, there are many strategies possible for facts, for addition and subtraction, and even a lot more than in our text. And on the screen here, there are some that we're going to talk about. Begin to know there are many more than this. And it's helpful to give them a name, kind of like having a toolbox of tools. It's helpful to have a name we can use with students to think about it. So let's take a look at 8 plus 6 and think about some of the names that we have for some of these. All right, I'm going to put on my document camera for a second. Let me pull this back up. There we go. Okay. Oops. So let's take a look at 8 plus 6. You know, one strategy for that is a common strategy. It's called the making 10 strategy. And once students are knowledgeable of their combination of 10 facts, where the 10 frame we talked about helps a lot, just the idea of seeing 10 in a lot of places. For example, I know 8 and 2 more makes 10. So basically it becomes a matter of decomposing one of the other numbers to get the number that we want. So for example, here if I break the 6 down to 2 and 4, I know 8 and 2 more makes 10, and then I can add on the remaining 4 to get 14. And that works just the same as if I had realized, well, I know 6 and 4 makes 10, so I could take 4 from the 8 and add the remaining 4, and I get my 14. And that's an example of the make 10 strategy. Well, we can also talk about the one called using a 10. You know, students are often more quick to be good at adding things to 10, as we see with the 10 frame and teen numbers, that instead of saying what's 8 plus 6, they might replace one of the numbers with a 10. For example, we can take a look at just 10 plus 6, and I know that's 16. But I wanted 8 plus 6, which was 2 less. So I know 2 less, I can count back, 15, 14. It's going to be 14. And I could do the same thing with the 6 as well. And so we have that. There's also strategies that have to do with double strategies or near double strategies. For example, if I want to do 8 plus 6, I might say, well, I know double 6 is 12, and that's 2 more. So I would add 2 on to the 12, and I would get my answer of 14. Or a student might say, well, I know double 8 is 16, but that one's 2 less. So if I take away 2, I get my 14. And one more strategy that you can see, of course there's many more than these, is the idea of using 5 as an anchor. You know, with that 5 frame we talked about the other day, a lot of students start to see numbers in terms of 5. And so, for example, if we were looking at 8s, we might see it as a 5 and a 3, and a 6 as a 5 and a 1. Knowing they both are made up of a 5, I could know that that's a 10, and the leftover pieces make a 4, and I could get 14. So it's just that we can see many different strategies. You know, these are 4 of them for that question, 8 plus 6. So let's take a look at a subtraction question. All right, how about 13 minus 9? I want you to do the same thing and think about it for a second. What are some different ways to think about 13 minus 9? All right, well, let's take a look at that. So 13 minus 9. In our text, Vanderwall talks about one of the main strategies for subtraction is just being able to realize that all subtraction and addition facts are related. You know, after we are getting better at addition strategies, well, why not turn this into an addition problem? For example, every subtraction fact we know is 13 minus 9 is something. So thinking about it as an addition fact says, well, then I know that working backwards, 9 plus something would have to be 13. And so it's being able to see the relationship there of going through and taking a look at that. And, sometimes we see different types of tools for this, like flashcards and things that the kids get used to seeing the whole, the part whole relationships, and realizing that 13 minus 9 is 4, or 9 plus something, 4 is 13. And we can do that. We can do it with counting on strategies. Again, 9, 10, 11, 12, 13. I know that I have to add 4 more on. Or again, I could think about getting to 10, 9, and 1 more is 10. And I need 3 more to get to 13. So just ideas like that as well, just are different ways we can think through that. And there are other ways as well. For example, we could talk about a strategy that Van de Walle talks about down under 10. And if we were doing down under 10, it's just the idea that I can always use 10 as kind of a stopping point on my way of subtracting 9. For example, I might say, I don't know 13 minus 9, but I know 13 minus 3 is 10. And once I get to 10, I still have to take away 6 more. And since I know my combinations of 10 well, I know that that would be 4. And again, there's lots of visuals for these strategies as well. Using an empty number line, I might say 13 minus 9 would look like this. Well, I could take 3 away to get to 10, and then I know I still need to take away 6 more, so I know that taking away 6 would be 4. It would get me to 4. And another one in our book it talks about is take from the 10. And this one's an interesting one, and we'll see a visual of this in a second. But it means 13 minus 9, well, again, why not break down the 13 into smaller parts to begin with? And take from the 10 says, well, 13 minus 9 is hard to think about, but I know 10 minus 9, that's just 1. So 10 minus 9 is 1, and then I still have this 3 hanging around, so I put it back on, and I get 4. And that would be called take from the 10. So these are some examples of different types of reasoning strategies for some addition and subtraction problems. And in our textbook, Van de Walle has lots of different ideas and activities that can be used to help students think about these. Some of the strategies are, just very basic. For example, one he talks about is adding 1 or 2. And he just talks about some different types of games when working on that strategy specifically. You can imagine a spinner and a dice, like in the top one, where you roll a 10-sided dice and spin the spinner, and the goal is to work on adding 1 more or 2 more to that number. And visually in the bottom left, we see again the idea of just visualizing. Students can have these little map puzzles and put a number in the middle and think about 1 more, 1 less, and just get used to those words and just used to the idea of adding 1, adding 2. Now, with a lot of strategies like the make 10, you might realize, well, what are some ways students can help see that? Well, this is where sometimes those 10 frames come back in. For example, if we're adding 6 plus 8, we can use the double 10 frame. Double 10 frames are a great strategy for basic facts, and they help us, again, just get a visual for some of things that our brain is trying to do. So for example, if I was doing 6 plus 8, I might realize that I could make a 10. So for example, I could take 2 of the numbers up here to make a 10. And now I know this is the same as 10 plus 4, or 14. And that would be breaking down the 6 into 4 and 2, and that worked as well. I could also look at it, like this. So I could, what did I do? Sorry, 6 plus 8. Oh, there it goes up here. Is, again, I could break down the 8 and realize I need to take 4 from the 8 and pull those up here. And again, I can see it. Another way of thinking about it is making a 10 with the 6 and having 4 left for 14. And so a double 10 frame is just a nice way of doing that to go through. Yeah. So same thing with subtraction. Some of the things that were new, like take from the 10, 13 minus 9. If you remember, this is we broke down the 13 to 10 and 3, and it literally just looks like this. Well, I could take away 9, 7, 8, 9. And I've done my subtraction, so the answer is just what's left. The answer would be 4. And just a visual for the take from the 10, or the down under 10. 13 minus 9 just says, well, first, if I was doing this strategy, one thing I might do is first take away 3 here, because 13 minus 3 is 10. I can see what's left. And then take away the 6 I still need to take away to get to the 9. And when I do that, I get 4. Great. So those are just some visual strategies there to go through. Another thing we talked about was the doubles facts. Mandel talks about the doubles facts are ones that are often rhythmic or more common at place, and are ones that, as far as memorizing goes, become some of the ones that are most helpful to look at first. And with things like this, students get some fun ways to think about and visualize some of the basic facts. And there's some fun names for them as well, like you see here. And that these become an important foundation for a lot of reasoning strategies. For example, here's a little game to work on the strategy of near doubles. Let's suppose I wanted to figure out 7 plus 8. The way this works is students are supposed to say which doubles fact would help them get that, and how. So for example, they might say, oh, I'll put it on top of 7 plus 7, because I could use 7 plus 7 is 14, and this is just one more, so it would be 15. Or they might say, or I could use a doubles fact 8 plus 8, because 8 plus 8 is 16, but this is 7 plus 8, it's one less, so it's only 15. So that's just a little way of thinking about helping encourage that strategy. With 9 plus 8, I might say, oh, I could do 9 plus 9 is 18. So I know that's the fact I'm going to use, and this is one less. So it is 17 as it goes through. So there's some examples of some different strategies. Lots of them exist. So let's just reflect on this for a second. So we as learners may or may not have used all these strategies. I'm sure we didn't, but I'm sure we used different strategies as we learn these, and probably still do as adult learners. As a teacher, it's important that we get to know these so that, again, one, we're aware of student thinking as we hear things, but also can help coach, can help suggest strategies, can help know the right tools sometimes for students to help think about their facts in a different way. And a big question here that I often get from students. Oh, I lost my keynote. One second, let me pull that back up. There we go. Are students supposed to know all these as well? Like, should they be tested on these? And my answer to that is, well, no. The focus here is on strategies, on students learning strategies that help them, get the answer and be efficient and make sense of the questions. So, as students get exposed to these, they should be allowed to pick and choose the strategies that make sense and that work for them. I don't believe students should be tested on a test of like, here's the 7 strategies, show me all the ways to use each strategy. Well, no, they're still just figuring out their basic facts, but allow them to use what makes sense to them, to go through and think about it. It's not wrong to practice them, but in the end, students, it's like a toolbox again, and students choose the ones that make sense to them and go through. Also, we're going to talk about number talks in a class coming up. Number talks are just a great structure in class to help students share strategies, get exposed to strategies, and practice using strategies. And that's going to be a key thing in an upcoming class, to think about the structure for really practicing these mental strategies. When we look at this Common Core standards, I just want to show some sample standards that have to do with what we're talking about. For example, in first grade, here's a sample standard. Add and subtract within 20, demonstrating fluency for addition and subtraction within 10. The difference there is fluency is a goal of being more efficient, of being able to recall more quick by the end of first grade. But adding within 20 is they're saying using strategies such as counting on, so a counting strategy, making 10, decomposing a number leading to a 10, which when you look at that one, it's actually our down under 10 strategy that we did there. Using the relationship between addition and subtraction, so that's the idea of think addition again, and creating equivalent but easier known sums. And here they have an example of really a near double strategy. So in the standards, we see that they're encouraging the use of these strategies as well. Again, not rushing to memorization, but encouraging students to make sense and practice these. In second grade, basically, we see the same type of strategy, but instead of going up through 20, it goes up through 100. And then I bolded this one here in red. It says fluently add and subtract within 20, so using mental strategies by the end of grade 2. So this again, the standards do push towards memorization, and they're saying by the end of second grade, if students can add and subtract with all the numbers, that the answers are within 20 again, so all our basic facts of 10 plus 9 and 9 plus 8, that's kind of the goal by the end of second grade. But it didn't rush there. It spent a couple years using all those strategies as well. Now, in doing this again, some thoughts on approach to this. I mean, the old school of thought was, give kids flashcards and have them memorize it all. And you know what? For some kids, that works. They have a strength in memorization, that's okay. For a lot of students, memory is not, there's, just flat out just memory and like that is not going to be what creates long-term understanding or recall. So that's where these strategies come in. And for explicit strategy instruction, the idea that, it's in some cases, the teacher is going to model these strategies, show a visual, again, do a think aloud and show the strategies, have students practice it. And it's just, again, helping students get experience of seeing strategies and using them. But it would be a misnomer to think that that's the way it has to happen, that somehow the teacher has to show the students all these strategies. Mandel talks about guided invention, which basically, to me, says, look, students, our brains are powerful things. We all figure things out. We all try to make sense of the world, and we kind of figure things out. So often, it's okay to, again, have some times, and we'll talk about how number talks can be used for this, to give students questions and let them think about it and see what kind of strategies they use and share those strategies with the class as well. And just recognize that strategies can come from students, that they have lots of ways that their brain is making sense of it. And again, to allow them to be some of the inventors and showers of strategies. It doesn't have to just be the teacher, but those can be shown to the class as well and practiced by the class as well. So in chapter 9, it talks about, just the idea that we really want to focus on thinking strategies, to go through and make that a goal of the class and make that a theme throughout basic fact instruction. We want students to devise and share strategies. Again, empower them to think, how are you thinking about it? What did you do to figure that out? We want to give students ample time. It's not a rush. We're not rushing to memorization here. We want to spend time and allow that to happen with a progression over time. And allow students to choose the strategies that work for them, as we talked about. These are tools, not rules, and, and just, through, again, we can use different types of word problems and story problems, different contextual things in class of just, allowing this to not be totally isolated from real world situations. So allowing stories, again, to come through and create a need for finding these answers. So I want to have a quote from Van de Walle. When in the text, he says, "Because mastery of a basic facts is a developmental process, students move through stages, starting with counting, then to more efficient reasoning strategies, and eventually to quick recall. Instruction must help students move through these phases without rushing to memorization." And it's kind of a big idea of this first part of our video today. Well, with that said, let's take the second half of the video and talk about multiplication and division, and think about some of the different strategies that occur as we reason through these. Well, first of all, it's important again to think about with multiplication and division, just again, we're always building on something in math. What are we building on? Multiplication isn't something new. We want students to see it as connected to all of the things they've been learning. So obviously with first learning, that multiplication is built on and connected to ideas of repeated addition. For example, a girl had 7 awesome puppets, and each puppet had 2 eyes. Now, how many total eyes were there? Well, with addition, we could draw out pictures, we could think about it, we could think about, well, there's 7 puppets, each one has 2 eyes, so that's 2 plus 2 plus 2 plus 2 plus 2 plus 2. And so really we're looking at 7 2s. So multiplication just becomes a way of helping students realize that 7 times 2, well, that just is a shorter way of writing 7 2s. 7 times 2 is just that idea. We have 7 puppets with 2 eyes. We want to add up 7 2s. And again, that's all we can think about. That's what multiplication means. And it's the same question we did before, just a different way of posing it. So helping students see that connection is really vital. And this is where we see how skip counting becomes a really big foundational principle for multiplication. And it is a skill that's worked on in the early grades and the standards. And, and so 7 times 2, we could realize that's 7 2s. 2, 4, 6, 8, 10, 12, 14. And being able to, use previous strategies, again, we could solve multiplication problems with lots of different types of skip counting strategies. There's lots of suggestions in the book for building connections to this. One of them is the idea of, groups of. Again, 5 times 3, this language is 5 groups of 3. And again, students can look at it and use strategies of grouping these together, of counting by threes. And again, as we realize that the new way of writing it in math would be 5 times 3. And that language of 5 groups of 3, or 5 times 3, is just a really good way of starting to build in conceptual foundation of that. And we could look at what does 3 groups of 5 mean? We get the same answer. Interesting. So 5 groups of 3 is the same as 3 groups of 5. Huh, that's actually the commutative property. And what a great thing to see visually, as we start exploring concepts of multiplication. So what I'd like to do here is show a kind of an interesting way also of visualizing multiplication. And so here we see groups of type visualization, but an array is also a very common structure to look at multiplication. And I'd like to share with you just an interesting idea that I saw in a math teaching journal here about using an array like this to, think about and visualize multiplication. So, for example, here we have an array, and we'd have students figure out how many are in there. There's 100. How did you figure that out? That could be a good question as well. But I like to talk about a parade. I like to ask students if they've been to a parade. We talk about parades for a minute, and I tell them this is going to be our parade. And it's a parade of drummers going down the street. But we're going to make all kinds of different parades. And the top numbers tell us how many drummers are in each row of a parade. So for example, a parade like this would have 10 drummers, and this would be 2 rows. So 2 rows of 10 drummers, or 3 rows of 10 drummers. But maybe we didn't have that many drummers. Maybe we only had 5 drummers in a row, like 3 times 5. Well, they'll make that connection, but 3 rows of 5. So it's interesting, this visual here helps us do this. And let me show you something. Like if we encourage students to start making different types of parades, like this would be 3 rows of 5. And again, I'd want to get the total. So I might do 5, 10, 15. And I tell them, put that number in the bottom left. So that way we know that we looked at that parade. And we can make all kinds of different parades. This parade would be 4 rows of 4 drummers. So how can we figure out? Well, you could count it. We could also do 4, 8, 12, 16. I could put that here. And we could go on and make lots of different types of parades. This is 3 rows of 4. That would be 12. Here's 2 rows of 3. Here's 3 rows of 3. And we could go down a bit. 7 rows of 3. And again, I could count by 3s and see it in different ways to get 21. But what's happening here, it's interesting, as we keep doing that, we basically are making a multiplication table. If we were to, keep doing this, I'll just fill in some here. That's, as we looked at this, it quickly comes to bear that really what we have here is a multiplication table of 5 groups of 4 is 5 times 4 is 20. But we have a visual that goes along with that to think about it in terms of what that means. 5 groups of 4, or 5 rows of 4, all the way through. So just an interesting way to use an array to develop a visual for thinking about just seeing what multiplication looks like. And in both these cases, the groups of and the array, the idea is to help students visualize when they see something like 5 times 7, what does that even mean to them? Oh, that's 5 groups of 7. Oh, that's like 5 rows of 7. It gives us that visual to start thinking about what that even means. So, as we work towards more mental strategies, well, we're going to need some different types of reasoning strategies again to work towards that, just to use some thinking in our head or some jotting down of ideas here. So for you, again, I encourage you to pause the video and think about these 4 for a second. And a key question here is if you didn't know these facts, how might you figure it out? Or how could you use other facts that you likely know to help? All right? So, for example, 6 times 8. Well, I know it's 6 groups of 8. So, of course, I could do a big drawing. But that may not be very efficient. But maybe I know, well, I'm good with my 5s. Oh, 5 times 8, I know those more. I know that 5 times 8 is 40. So 6 times 8 would be one more group of 8. So that would have to be 48. Or maybe 4 times 9, I might think, well, 4 times 10 is 40, I know that. So 9, well, that'd be having 4 less. So that would be 39, 37, 36, going that way. So again, just like addition, there's different kinds of reasoning strategies we can use, and let's take a minute to go through some of those. We're going to look at some scenarios and take a look at some different strategies. Like in the Van der Waals text, there's many, and there's many more that aren't in the text as well. And some of the ones you hear about are using doubles, using 5 facts, zeros and ones, using known facts to derive other facts, halving, breaking apart, using squares, things like that. So let's take a look at some scenarios and take a look at some of these in play here. So, for example, let's take a look at second grade student Anna, who's displayed a growing mastery of basic addition facts, but still struggles to quickly calculate problems with 2's, like 8 times 2 and 2 times 6. How might you help Anna? So in this section, I encourage you to pause the video after each question like that and just think about it. Think about it and then unpause it to hear one possible answer. All right, so with Anna here, again, a big thing is making connections. So for students, as we're seeing any fact that's times 2, we can realize again that this is the same as a double fact, right? 8 times 2, it's like having 2 8s, right? So 2 8s, well, is a double fact. That's like my double fact 8 plus 8, which I know is 16. And 2 times 6 would be 2 6s, or double 6. I know that double 6 would be 12 going through. And as students realize, like times 2, just as like a double fact, it tells me which fact I have 2 of, is just 2 8s, 2 6s, 2 groups of 8, 2 groups of 6, that connection is a quick one to make there. And so Van der Waals talks about connecting to our doubles facts. Well, let's say that someone realized that, and they realized that anything times 2 was just double the number, like Dante does here. How could that help him with his times 4 facts? Or his 3 facts, right? Think about that just for a second, and then, pause the video and think about it, and then unpause. Okay, well, let's look at this. So this idea that strategies can be used in a lot of places. For example, if I know my doubles facts, it might be something where I realize anything that I have a 4, well, I know 4 is made up of 2's. So that means I could do double 7, I know that's 14, and I could double 7 again to get another 14, and together that would be 28. So it's interesting, it's just double and double again. And I could, it's different ways of thinking about it. I could get 14 and double 14, or I could add them together. But the idea of seeing that when I break down 4, I could double that up. In fact, it's not the most efficient strategy, but I could do that with any 6 fact as well, because any 6 fact I could break into 3 groups of 2. So 2 times 7, 2 times 7, 2 times 7, seeing as double 7, double 7, double 7, and being able to think about this as well. Now, it also relates to the times 3 fact. Any times 3 fact, I could see it as a double and one more set, because I know that every 3 breaks down to 2 and 1. So I could do a double 7. A double 7 is 14. And then I need one more set of 7. So together, that would be 21. So it's breaking that down to, again, double and one more set. And so we see how using a double strategy, it can be applied to things like times 4 and times 3 facts going through. And I encourage you to maybe think about 8 times 4 and 8 times 3 there, and pause the video to try that out. So let's take a look at Philip. Philip could skip count by 5s very well after practicing with nickels, one way of using skip counting of 5s. So he was pretty quick with his 5 facts, like 6 times 5 and 5 times 8, because he learned to see it as 6 times 5, he learned to see it as 6 groups of 5, 5, 10, 15, 20, 25, 30, or 5 groups of 8. 9 times 5 would be 5 groups of 9, and seeing it as a way of thinking about it as as 9 groups of 5 or 8 groups of 5. I was thinking about using 5, so it would be 8 groups of 5, 9 groups of 5, and so forth like that. And if we have those 5 facts, we can use those facts to help us with many other facts like the ones there. Pause the video for a second and think, how would that help you with facts like that? think about that and try and write something out for a second. So let's take a look. So with our 5 facts, I might take a look at something like this. Well, instead of 6 times 6, I might realize, well, I could instead do 6 times 5, and think about it, a fact I know instead. Because I know 6 times 5 is 30. That's 6 groups of 5. 5, 10, 15, 20, 25, 30. But I was looking at 6 groups of 6, right? So here, I only had 5. I need one more group of 6 to add on there. Because, again, I took one away from here. So I still need one more back. That'll give me one more group of 6. And so that would give me 36. Or, just like any of these, like down here, again, actually I'll maybe do 4 times 7. And to realize, well, with this one, well, I know 5 times 7. Again, it's the same as having like 7 5s, 5, 10, 15, 20, 25, 30, 35. I know that's 35. But I only wanted 4 groups of 7. So that means I have a group of 7 too many. So if I take that away and bring that back, I would get down to 48. So the idea of either overshooting or, undershooting and adding up, or going too high and readjusting, is just using those 5 facts to accomplish that. And one thing with this is I want to make a special note, is that all this doesn't need to be in your head. Like I'm doing here, it's okay with basic facts, even though the goal is eventual memorization in our head. As we're figuring it out, it's okay to write strategies down, to model what the thinking is, to let students do that as well. That's perfectly fine in the phases of working through reasoning strategies. How about this? Here's a student's question. My dad said that when you add a number plus 0, you always get the same number. But when you multiply a number by 0, you always get 0. I don't get it. Can you help me? Well, let's think about this. How would you answer that? So maybe pause for a second and think about it. So let's think about multiplying by 0 for a second. So, if I think of something like 8, times 0, well, first of all, using our groups of language, this would be 8 groups of 0. So if I actually drew it out and these are my groups here, and think about it, if each group has 0 things in it, then how many things do I have total? Well, none. Yeah. For example, if I had 8 trick-or-treaters come to my house, and I gave them each 0 pieces of candy, how many total pieces of candy did I give away? Well, none, of course. And that's what 8 times 0 means, like 8 groups of 0. Yeah, it's just a way of thinking about it. If I have a job that makes $0 an hour and I work 8 hours, how much money am I going to make? Not a very good job, by the way. But again, putting it back in context, thinking about it, the idea is to make sense of it. We don't need to just say anything times 0 is 0. We can think about what it means. And again, tell a story. Think about connecting it back to our language of groups and things like that to make sense of that. Rather than focus on a rule, focus on making sense. So, how about Nora here? Nora, a 3rd grader, was getting quicker at answering multiplication facts, especially with numbers less than 5, but she struggled to efficiently compute her times 9 facts. What are some ways to help? Well, first of all, there's a famous finger trick for 9 that's really more of a trick more than a strategy. But I'd like to, if in class, people always bring this up. And so I want to look at that, but then we're going to look at some other strategies here. This is kind of just a fun one. Is if we're looking at, times 9 facts, there is a way of looking at your fingers to get this. For example, if you want to do 9 times 4, what I do is hold up my hands, and I start from the left side, and I count to my 4th finger. 1, 2, 3, 4. And then there are numbers on the left of the down finger and on the right. There's 3 fingers on the left and 6 on the right. And letting those be digits, I would have 36. And that's what 9 times 4 is. Interesting. Let's try it again. How about 9 times 6? 1, 2, 3, 4, 5, 6. Put that down. That would be 54. Does it work for 9 times 9? Let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 81. It does. And that's an interesting little finger trick, but it is a little trick without understanding why it works. Not that tricks are bad, but I do want to have the focus be on sense making and reasoning. So the 9 facts are kind of fun because there are so many hidden patterns in the 9 facts. And I'd like to make a little list here for a second of our 9 facts. Yeah, and yeah, I'll go to 10. When we look at our 9 facts, if we start looking at this, if we look at it as, 9 groups of 2 or 2 groups of 9 and start thinking about these, as we reason different things out using our groups of, I just want to take a look at the answers here. And this is something I like to do with students as well, is I like to put this on the board and encourage them to go on a pattern hunt and to find all the different cool patterns that they can find in our 9 facts. So pause for a moment. What patterns do you see? What are some things that you see when looking at all the 9 facts in a row? Pause the video just for a second and take a look. Well, some of the things that students often come up with is they realize that in the answer, they notice that, for example, in the tens place, it goes up by 1 every time. 1, 2, 3, 4, 5, 6, 7, 8, 9. They notice in the ones place, it goes down 9, 8, 7, 6, 5, 4, 3, 2, 1. Or let's say it counts up this way, 1, 2, 3, up to 9 this way, which is kind of cool. Some also realize that the answers, the digits always add to 9. 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9, 4 plus 5 is 9, and that's kind of cool. Other students realize it's kind of interesting that the number you're multiplying by, the answer is always 1 less. So the answer is always 1 less. That's kind of cool as well. In fact, for me, that's how I always thought of my 9s facts growing up. When I thought about 9 times 6, I thought of this pattern, and I knew the answer would start with 5. And I knew that the answer had to add to 9, so I would go 5 and 4 more, so 54. So in my head, and I wonder if any of you do this as well, when you, or still do, or did as when you were younger, 9 times 7, I know the answer would start with 6, or 60, and I know it has to get to 9, so 3 more makes 9, 63. And that goes through there. Now, in these, there's lots of strategies, though, to get this, and the biggest thing with 9 facts is probably using 10 facts. For example, 9 times 6, a lot of students will say, I know 10 times 6 is 60. Right, but I only wanted 9 groups of 6. So 10 times 6 is 60 is great, but I need to take away one of those groups of 6, and that would get me the answer. Or, 9 times 4, same thing. I know that, I know 10 groups of 4 is 40, but 9 groups of 4 is 1 less. So if I take away 4, I would get 36 for 9 times 4. And so relating to a 10 fact can be a good way. So there's lots of interesting things with the 9 facts as we go through. What about things like this? I mean, there's so many strategies for multiplication as the book goes, and I'm just trying to run through some of them. And, some of them may be new to you, so just getting you exposed, and hopefully you can pause the video as well and try a couple on your own. How about Tyson here? Tyson was thinking about 8 times 6. I don't know 8 times 6, but I do know that 4 times 6 is 24, so I can use that twice and get 48. Yeah, what Tyson was doing was called a half, then double strategy, and this is a really helpful strategy that a lot of kids like, a half and double strategy it's called. And so let's take a look at a half and double strategy. So all it's saying is, 6 times 7, maybe that's big, but I know half of 6 is 3, right? So again, it goes back to the idea of taking a look at it and seeing, I know 3 times 7 is 21, and that was exactly half the 6. So, the answer to this problem would be to take the other half. There must be another 3 times 7. And so if I know 3 times 7 is 21, I can just double that to get my 42. So it really works with any even number thing. So again, 8 times 5, what that sounds like again is I might say, I know half of 8 is 4, and I know 4 times 5 is 20, and that's half the answer. So I could just double that and get 40. Right? So there's just different ways of having and then double is another really efficient strategy for any question that has an even number in it. So that's a really powerful strategy once we get there. Yeah. Now, some of this you might say is, this is great, but some students may need something a little more visual. And in school curriculum, there's something that's used often called the break-apart strategy, which is kind of the answer maybe you've been looking for. And let's look at Marielle here. She was thinking about 8 times 7, and she thought, I know 8 is the same as 5 plus 3. True. 5 times 7 is 35, 3 times 7 is 21. I put those together, and I get 56. Well, that's a lot of thinking in our heads. That's where a visual comes into play. And let's take a look at 8 times 7 here. And let's just show you a strategy here called break apart to visualize that. So when looking at 8 times 7, or any fact, what we can do is use a rectangle. And we're going to use this rectangle for a break apart fact. And so, for example, if I want to break apart the 8s, what I can do is just decide what I want to break it into. Maybe I want to break 8 into 5 plus 3. And the other number I'd put over here. And as I break it apart into smaller numbers, then maybe it's helpful. Maybe it's easier for me to think about 7 times 5. Again, a 5 fact is 35. And 7 times 3 is maybe a fact I'm better with. It's 21. And if I add those two together, I get my total of 56. So it's a visual way, and you could do it lots of ways. For example, obviously like with our half and double strategy, let's say I wanted to take 8, since it's kind of the bigger number, and break it into 4 plus 4. Well, I need to multiply that by the 8. This is a visual structure for multiplication, and I know, I know 8 times 4 is 32. I'm sorry, there'd be a 7 over here. I broke apart the 8 up top, sorry. Oopsies. 7 times 4 is 28, and that is also 28. And so I could add those together and get my 56. And I could have broken apart, maybe I don't like 7s. You know, if I don't like the 7s, I could use this strategy to say, instead of 7, I'd like to break it into 5 and a 2. I like my 5 facts. And I put my other number over here that I didn't break down. So, yeah, I know 8 groups of 5 is 40, and I know double 8 is 16, so that one would be 56. The break apart strategy is actually a very helpful visual strategy because it's a way of using a lot of the other strategies but see it visually as we go through, and it's quite powerful. So on your own, can you pause the video and can you try one for, let's do 6 times 9 or 7 times 6. Why don't you pause and try at least one of those for a second. Yeah, so in this strategy, we always start with a rectangle, and I'm going to break it up, and technically I could break it up into more than 2 pieces, but so maybe it's that 9 that's just too big for me. And again, maybe I like to anchor to my 5 facts. So going back again, I might break the 9 to 5 plus 4, and now I could think about my times 6. 6 groups of 5 is 30, and 6 times 4 is 24. And I could use other strategies too. I might say, oh, what is that again? Well, let's see. Well, I know 6 times 2 is 12, and double that is 24. So it just all can go back together here. And again, you could have broken up, maybe you did it the other way as well, to show the flexibility here. There's really no wrong way to break it up. Is maybe I want to break apart the 6, and maybe I like the 6 into 3s. And I could do, oh yeah, because I know 9 times 3 is 27, so it's 2 of those. Add those up, I'll get my 54. So this rectangle or break apart strategy is a great way to scaffold some of the visuals of thinking about many of these strategies that we just did. I think there's a lot of power in that visual. Now, we haven't talked about division at all, but like subtraction, I think the key is not to make a whole bunch of new division strategies, but to realize again that division and multiplication are related, and to try and use our multiplication strategies to solve division. Again, there's lots of different ways students can think through it, but for example here, Dante is trying to figure out what's 72 divided by 9. Well, the key is here to realize, again, our multiplication facts is the idea that this is also a hidden multiplication facts. Every division problem in reverse is multiplication. For example, something times 9 is 72. 9 times something is 72. Or 9 groups of something is 72. And it just helps us think back the other way and realize, go back to my 9 facts and use my 9 strategies to go, oh yeah, 9 times, let's see, 8 was 72. Yeah, so that means 9 must go in 8 times. And just thinking about that. And so, yeah, 56 divided by 8, again, think multiplication. So that means something times 8 is 56, or 8 times something is 56. And going back and looking at my my facts to think about that. What would that be? And it even is possible, if we wanted to, I mean, just to show again using that break apart strategy, if I know that it's 8 times something is 56, I might think about something like this. Well, I don't want to go too high, but I know 8 times 5 is 40, and looks like I'm getting closer. I think I would need 2 more 8s to get there. 2 times 8 is 16. Oh yeah, definitely. So 7, 8 times 7 is 56. So again, you can go back and even use the thinking of the break apart strategy to kind of do it in reverse to go through. So that's the main strategy I want to talk about division, is thinking back in terms of the multiplication facts. So in Van de Walle, I encourage you to make sure you look through this chapter. There's a lot of really good stuff in it, a lot of games and things, ideas in there that are hard to do over a video like this. We'll do some in class, but just think of ways to make it a little more interesting. He talks about what to do. He encourages you to have kids focus on self-improvement and self-monitoring, maybe keeping chart of which facts they feel like they have down, which ones they need to improve on, and that if we're going to drill, that it's really not about time tests and drilling. There's no reason to have to rush, students to stress out in time tests. I think the important thing is allowing time to think and reason as we push towards learning, towards memorization. The goal is not to try and force it with forcing students to take these stressful, timed tests. There are people, and I'm not going to state never, we'll talk about it in class as well, but, there are some things about doing some shorter timed, little quizzes. I would encourage not for like a big grade, but more for a self-check of where students are at. That helps, again, push students to think towards memorization. But the idea, again, shouldn't be on grades and getting a big test, but on self-monitoring, self-improvement, of keeping track of which facts I know, which facts I need to work on, and going through that. And we're going to see it in class, but a lot of ways to make drill enjoyable. There's lots of technology apps and games available to think about this. Our chapter has a lot in it that can be done even with families. And he says again what not to do is not to shame kids with public comparison, putting up charts that show which kids are further along. I mean, it's fine to have kids keep track of on their own where they're at, but you don't need to turn it into some kind of big competition where, again, kids who are taking the longer end up, again, with a lot of anxiety, feeling that they are just not as smart because I can't do it as fast. I think we want to send a big message as teachers is that, again, being good at math is not about being fast. Being good at math is about thinking carefully, and that's what we want to stress. I mean, sure, getting fast is helpful, but thinking carefully is the essence of a mathematician. It's also important to note, Van de Walle talks about that when we learn multiplication facts, we don't just start with like 1 and go to 2, and then 3, and then 4, and then 5. That, depending on the curriculum, often the 1s, the 2s, the 5s are often the places to start, and 4, and then going back to 4s. Don't think it's some type of progression. You have to go from 0 to 9 in order. And so I just encourage you to think about some of those things in the text, and I encourage you to look in the back of the chapter where he talks about helping students who are struggling, and talks about recognizing that student that's struggling, having them drill with flashcards is not the most helpful way, because, again, what they need is to focus on the reasoning strategies and get some practice and make sense of that to go through, and then that memorization will come. But just trying to force that memorization on a lot of kids is not the answer. Again, help that anxiety, provide hope. Let them know that they're improving and they're getting it, and they don't have it. They may not have it memorized yet, and that's okay. We're going to keep learning strategies, and it will happen as they continue to put in the time and the work. The inventorying facts is important. How do students improve if they don't know what to improve on? And this is where some of the shorter, little quizzes can be important, not for grade as much, but just about realizing, hey, look at this. Let's take a look at which ones you got right, which ones you got wrong. It looks like you got all your 5 facts right, but it looks like you got several of your 7 facts wrong. Let's work on the 7 facts. Let's talk about those. Let's think about what strategies we have. Let's focus on those, to think through, are some of the things we can think about. So as we wrap up this video, thanks for hanging in there. I know there's a lot today. Is that let's take a look at some connections to the standards. So for example, in 3rd grade, here's one standard. There's many more standards than this. I just wanted to show one sample here. It says interpret products of whole numbers. Interpret 5 times 7 as the total number of objects in 5 groups of 7 objects. I put this one in there because in 3rd grade, again, it shows how we're focusing, there's a lot of these, focusing on reasoning strategies, focusing on different types of ways to make sense of the multiplication facts. And there's many things like the standards in that. Now, after strategies, see by the end of third grade it says this: fluently multiply and divide within 100 using strategies such as the relationship to multiplication and division. Knowing that 8 times 5 is 40 allows one to know that 40 divided by 5 is 8. So that's, again, think multiplication strategy right there. And so, again, just using strategies, and there's a lot of them put in here. But here's the kicker. By the end of grade 3, know from memory all products of two one-digit numbers. So in the standards we do see, again, there's a focus on strategies, but there's also a focus by the end of grade 3 is when we have the goal for all students to have this committed to memory. I know this is something I like to say and put out there because sometimes parents especially think, what are we doing to all these strategies? Just give it the flashcards, try and memorize it. And I tell them, the goal is still the same. The goal, we do want students to get to that quick recall. But just tell students, parents, and things that we're just not rushing to get there, okay? We're going to spend longer building a foundation of sense-making and strategies and visuals, but the goal is there, so don't worry. We have the same goal in mind. And when we get there, the nice thing is when students may forget facts, they're going to have a foundation from which to fall back on to recreate it, to think, and to grow those flexible thinkers. Again, the number sense thinkers that we're looking for. So that's an overview of some thoughts on the basic facts, and this is a big topic, and we're going to discuss more in class. But again, hopefully you found some of these ideas interesting and new, and maybe raise some questions as well. And so hold on to those questions, and we'll talk very soon. All right, everyone, have a good rest of your day. Bye-bye.